will announce that it's being done. Yeah, okay, good. Okay, I see that most speakers are in. It's 1 o'clock. So I propose that that we'll start our session. Session 5.1 on circular building design methods and assessment, with many interesting speakers. First announcement is that I'm now mute you all, which is done right now. And the second announcement is that this session will be recorded. So if you don't want, if you want to stay anonymous, please use the chat and don't speak, because then you are recorded. But I guess that most questions and answers will go by chat anyways. Just to be sure that you know that it's going to happen. You are all on mute. The speakers will unmute themselves when they start their presentation. And if you want to see it full screen, you have to choose that option yourself. Each speaker has 10 minutes, and there's a Q&A at the end of this session. So I propose that we collect questions until the end, to allow the real full 10 minutes for each speaker. So the first presentation is from Michiel Ritzen, working at Hogeschool Zuid. He will show us an evaluation of 4 circular concrete scenarios, and it will definitely be very interesting to hear about that. Michiel, please go ahead, unmute yourself, and please share screen for the presentation.
Yes, thank you, Agnes, for this introduction. And actually, I'm going to present 5 concrete scenarios. And to be honest, I'm not a concrete expert. I'm an architect. This work has been mainly done by a close colleague of mine, Rick van der Boogaert, who has left our organization. I think I can manage to answer most of the questions, but if they're very specific on concrete, I might have to take them home and react on them in a later stage. So here we are with my presentation. Let me put it in the full screen modus as well. Okay. So, as a very brief background, we're working towards this decarbonization of the built environment in 2030, a transition towards a circular economy as well, 50% in 2030, 100% in 2050. And in our region here in Parkstad, we have a very large demolition assignment of about 10,000 dwellings and 150,000 meters of utility and office buildings and stores. So we have a very high amount of available materials in this demolition stock. And a lot of this material is actually concrete. And as you all know, probably concrete has a very significant environmental is very significant with its environmental impact related to the whole construction industry of about 40 to 60%. So at this moment, the rate of circularity is very low in the construction industry in the Netherlands. It's 3%, and a lot of this recycling of 95% is actually downcycling. We're not using the materials on this high level as what is possible. And focusing on Parkstad, we've made this inventory of these 10,000 dwellings and this 150,000 square meters. What is actually the main materials that are available? And here as well, we see concrete is one of the main materials. So in the Superlocal project, I presented it earlier today, and it was presented yesterday as well. We have 4 of these apartment buildings, and we're looking into how can we deconstruct these buildings and reuse them in the highest level possible. And we did this full inventory of all the materials, and here you see as well in the graph on the left bottom side that most of the materials from this apartment building is concrete. So focusing on concrete, we designed these 3 model houses. They're now finished, and all kinds of concrete was concrete was reused in 5 circular scenarios. The first scenario was we sawed and hoisted out these complete compartments. The second scenario was that we took out different slabs and slices. So we cut out slices, but for instance, the slices that you see lying here, that are the old division elements between the balconies. So we looked at how can we reuse these slabs and slices. The third scenario was that with the concrete rubble, we made recycled concrete and we made prefabricated elements. And the fourth scenario was that we recycled and made granulate and all kinds of fractions of this concrete rubble, and we poured on-site new concrete. And the fifth and last method of circular concrete reuse was that we made these very small, actually smaller brick elements that you could very easily mantle and dismantle again. So they would work a little bit like Lego blocks and can be put together. And we started first with an analysis of these 3 model houses of the circularity. And what was quite interesting is that we looked at the numbers and the data we had from already done research. And in that research, you could see that for the application phase of a building material, about 3% of the embodied energy is necessary. So mainly the embodied energy is in the production of materials. So that was a number we took with us when we did our first analysis. And the second number we took was that in the first rounds of data collection and calculations, we found out that recycling concrete was about demanded about 20% of the original embodied energy. But going in deeper, we found out that these numbers were much too positive. And here you can see the relative amounts actually of savings on embodied energy and embodied carbon compared to the baseline. And so, for instance, you can see that if we hoist out these compartments, due to the fact that we needed a lot of machinery and a lot of cranes, etc., to hoist them out, it was really not energy efficient at all. We didn't save any energy. At the moment, we looked at the optimization, so taking out 50 of these compartments, that's the maximum we can harvest from one apartment building, we could save 66% on embodied energy. So in that sense, it's a really good percentage and a good environmental impact saving we can realize with these with this solution. We see about the same number with the slabs, with the slabs and slices. There, the saving is even higher because you can use smaller machinery. But for instance, the prefab elements and the on-site pouring, and especially on-site pouring, was not energy efficient at all, actually, due to the fact that all the grinding and from the demolition towards grinding in these different grades and then reusing it again, there was no embodied energy saving actually at all. It was 16% more energy intensive than compared to creating something completely new. And here you can see here you can see these numbers again. So on the left hand you can see the baseline. So that's the standard demolition and new concrete development and new concrete pouring. And then you can see that taking out only these 2 compartments, which we did in the project itself, it costs a lot more energy. If you optimize that process to 50 compartments, there you can really see the savings. So compartments, hoisting out compartments, and even more interesting from an environmental perspective is reusing these slabs. And with that, I want to conclude this presentation. So we see that there's a lot of energy and CO2 savings possible with maximum potential. So if you hoist out 50 apartments, if you go below that number, well, it will be very difficult to have any environmental impact gains. And recycling of concrete has really only a minimal benefit. But there's a big but here. We didn't look at extracting the still reactive cement from the rubble concrete, because if you pour concrete, not all the cement has reacted, and if you can extract that, you can do some more savings here. There's some research going on in that field. If we improve or if we optimize the machinery use, we can improve some aspects, but the most important thing is that if we look now at such a building, it is not designed at all for disassembly and reuse on a compartment or a component level. And that is really something we have to rethink, that if we design these kind of buildings, we have to think about, okay, what are the end-of-life possibilities? Thank you.
Thank you very much, Michiel. It was well in time and still very interesting and very compact, nice presentation. I see that we received a question on this, which we'll keep until the Q&A at the end. We won't forget it. But to stay on time, we continue to the next presentation of Mrs. Jiang. She's going to tell you about product level circularity performance based on the material circularity indicator and also based on residual value considerations. So, Mrs. Jiang, yeah, I see that it's coming on the screen. Please go ahead, unmute yourself and tell us more about this. Yeah, great.
Yeah, okay. So now everyone can see my screen, right? So I can start. Okay. Yeah, thank you very much for having me. And this is Jiang. So today I would like to present the research that I have conducted during my master studies. So actually it is about circularity metrics that based on the MCI to measure the circularity performance. So we all know that actually the circularity transition is still in its early stage. So there is no recognized way of measuring how effectively it's making the transition from linear to circular, while standard measurements is quite important. So to guide users on the right directions on the ways of the circularity transition. So my general objective is to develop a tool for monitoring the circularity progress, while it's too challenging to develop a completely new method. So in my research, I focus on the material circularity indicator, or MCI in short, as my starting point. Actually, the MCI is one of the most famous circularity framework. So I guess maybe most of you guys already heard about this method before. So consider limited time, I would like to introduce the limitation that inherent in the MCI directly in this presentation. So we all know in a circularity matrix, the units are always used to represent the material's value, while the mass flows used in the MCI, that means the material with larger weight always has higher value. So it's of course unreasonable. So the main drawback of the mass floor use is in its capabilities to make a distinguish between the relative value scarcity of different materials. So then my question would be like how to recover the issue of the mass floor to represent value scarcity in the MCI. And furthermore, there are another, sorry for my presentation. And another limitation is about the MCI assumes the quality and the quantity of the products after end of the life is as the same as the new one. So that means the residue value is after end of life is equal to its original value before its usage. And also, actually, this is one of the most common limitations from the existing circularity metric, because most of the circularity metrics using the physical measurement units like the volume or the mass floor in the MCI, so which fails to capture the value changes throughout the whole time. So in short, that the MCI examines over-optimistically about the embodied value of asset in a closed loop. And it is widely agreed that there is a close relationship between the circularity level and the residue level value. But it is very strange. There is no even approach that considers the residue value as an independence indicator. So then I'm thinking maybe it is meaningful to build an independence indicator residue value in the circularity metric. While instead of just simply build the indicator, it is quite fundamental to think about how to quantify it. Why it's not easy? Because there's not a specific way that can be found from the literature that can assess the residue value of products of materials directly. So then my question should be like how to measure the residue value of materials to support the circularity assessment in the MCI. So then with this introduction, I can make like my objective become more concrete. So that is to develop a circularity metric by recovering the limitations inherent in the MCI at the product level in the construction center. And also two research questions has been developed corresponding with two limitations that I have introduced before. So I also have developed a research methodologies with 4 phases. So starting with phase 1 about the literature review, and the models have been developed in the phase 2. And it should be mentioned that before developing the circularity metric in my thesis, I also developed a simple tool named residue value calculator, so which is mainly used to assess the residue performance of the materials. So that can give the value of the independence indicator, which I would like to build in my circularity metric later. So then these complete models will be validated and the testings in phase 3, and leading to the possibilities of drawing us some conclusions in phase 4. So in my thesis, I discussed the results actually following each phase, while in here, considering the limited time, I directly introduce my model in phase 2. So here is the overall look of my models. So you can see that actually in here, I develop a residue value calculator, so which can be used to assess the residue performance for the independence indicator R in here. So then to support the overall assessment of the whole circularity metric. So then let me introduce a little about how it looks like for the residue value calculator. So this calculator is still in its early stage. So currently, I only consider 2 groups of the factor, so like the deterioration factor and also the design strategies. So it is assumed that if more efforts has been focused at the early stage or at the design stage, then the residue performance or residue value can be maintained as much as possible. So specifically for the design strategies, I focus on the 2 most important like design factors. For example, like design for disassembling or design for recovering. So I also developed some mathematical functions referring to some scholars to assess the design strategies in a relatively objective way. And also for the deterioration factor, I also consider the physical deterioration and the maintenance measure, these 2 factors, and then designed a 2 phases reliability function to assess the effects of the deterioration factors on the performance, on the residue performance in an objective way. Then I would like to introduce the most important parts on my thesis about the circularity metric. So I also maintain the advantages of the MCI. So that is following the principle of life cycle thinking. So in my metric, I consider the input, the utility, and also the output. And furthermore, the circularity matrix was modified from MCI by recovering these two limitations as I introduced before. So for examples, when calculating the input parts, I use a new measurement unit, E, in here, which is used to represent the economic value of materials to replace the mass flow used in the MCI. And similarly, when calculating the output, I also using economic value of unrecoverable waste to replace the mass flow, and also integrated a new independence indicator R, which is the residual value of materials in here. So that is can then measure the circularity performance from an economic perspective in a more reasonable way. So similarly, I also revised a most important indicators named linear flow index, which is used to measure the proportions of materials flowing in a linear fashion, combining the inputs and output, and also maintain directly the utility factor from the MCI. So overall, then I can, by recovering these two limitations, I can create a new functions to assess the circularity performance, or called MCI prime in here. So I'm quite sorry that I just briefly introduced the methods, because it would take too much time to go deep into the mathematical functions. So I would like to invite you to look into the papers or this PowerPoint later if you're interested in these methods. So then with the complete model, we go into the phase 3 about the validation. So this phase is mainly about to understand the effects of each and combine this adjustment on the overall circularity performance. So it should be mentioned that in here, I use a real project provided by platforms in the Netherlands. And instead of focusing on the whole building system, my method is mainly designed on the product levels. So in here, I focus on the facade, on the project directly. And also I have to create the different scenarios in order to validate my methods in a complete way. For example, in the base scenario, it is assumed that the materials is assumed in a linear, following in a linear procedure, and also some circular methods has to be assumed to be conducted in different other scenario. So here you can see some of my results. So the validation process is following with the different steps. The step 1 is mainly focused on the first limitation or the first adjustment in order to understand the differences of using mass flow or using the economic value. So in here you can see that actually when I using the mass flow in the MCI, the performance scores are almost maintained the same. This is because the facade was created by using a kind of lightweight while really costly materials. So then you can see that when I use the economic value instead, then the performance scores can be different. So it can distinguish the circular measures using in different scenarios. So I believe that the economic value is a more reasonable measurement unit, especially in a situation where lightweight while valuable materials are used.
Lee, are you going to the conclusions?
I guess 2 minutes is enough for me. Is this okay?
Yeah. 1 minute.
Okay, I'm quite sorry for that. So then it's about the step 2. So to evaluate, to assess the residual value. So and then I can to examine the effect of the R in here. So you can see that actually when I integrated the R show differently. The effects show differently in different scenarios. So it's quite easy to understand because, for example, when R is smaller to 1, that is mean the material's value decline with time. So under this conclusion, which means we need to focus more or put efforts more on the input rather than the output, because the value involved in the input is much than the output. So then when I integrated this indicator, that can be distinguished between the input and output. So then finally I go to my conclusion. So in here that in my thesis, I develop a new methods based on the MCI and mainly focus on the two limitations. The first one is about the mass flow, and then I also build an independence indicators, then residue value, and also build a calculator to assess this indicator as well. Yeah, thank you very much for the listening.
Thank you very much, Lee. It was very interesting to hear about these developments, because we all want to measure circularity for sure. We continue with the next presentation, because circular economy is not only about measuring, but very much about cooperation and collaborative approaches, which we will hear from Professor Paula Femenias, if I say it correctly. Thank you. And you are going to tell us something about collaborative approaches in kitchen designs. Thank you. Go ahead. Yeah, you see the slide. Maybe you can put it on presentation mode.
Now you can hear me?
Yeah, very far away.
Very far away. It doesn't connect to the. Yeah, I hate it. It's because the Chrome probably doesn't fit to my.
We can still hardly hear you, Paula.
Yeah, I don't know what to do. I don't know what to do.
Maybe the speaker can be put. Okay, then you have to speak loud.
I don't know where the sound comes from. If it comes from this or here or anything, I don't know. I'm sorry. I have the Mac and I have this problem Monday for another conference, so I don't know. I'll try to.
Okay, shall we? Otherwise, yeah, because we really can't hear you. Now we can't hear you at all anymore. Given the time frame, which is very short, maybe there are some suggestions in the chat. Maybe you can restart again, Paula. And I propose that we continue to the next speaker. Otherwise, we're going to run out of time. And Paula, give me a hand when you are back in the session. So yeah, I see that the next speaker is ready to jump in. Thank you. Then we first take the presentation of Dr. Mark Kelly from Ireland, telling us something about circularity and assessing circularity in small-scale construction projects in Ireland. Yeah, Mark Kelly is taking the screen. Can you unmute yourself also, Mark?
Yeah, it should be unmuted now. So
we hear you. Yeah, great.
Yeah,
go ahead, and Paula, please try if you can find a solution. Maybe log in again or whatever. Go ahead.
Okay, so thanks very much. I just want to maybe divert a little bit away from a lot of the discussions over the last couple of weeks or last couple of days, which have been focusing on design interventions, and look at it from the perspective of a SME main contractor. So just a bit of background for myself. I'm based in the Department of Building and Civil Engineering in GMIT. And the findings today is from ongoing research that's exploring how the circular economy principles can be integrated into small-scale projects in Ireland. And I suppose my background over the last 20 years has evolved from looking at construction, demolition, waste management into resource efficiency best practice on site, and now into the circular economy. And I suppose that mirrors where we are as an industry as well in Ireland, and we follow this sort of trajectory. And the circular economy, which I'll outline the next couple of slides, is beginning to gain some traction in Ireland at the moment, following on from best practice in the EU. So I suppose this is the problem, really. You know, the link between construction output and construction demolition waste production. So on the graph here, you'll see that a gradual increase from 2014 to 2019. But if we put this graph back to 2007, we were actually at a figure of 18 million tons, And that figure only dropped to 3 million tonnes in 2014 due to the economic crash. So we can see a direct link, obviously, with economic activity, construction output, and C&D waste production. So the aim really is trying to decouple that. As production increases, can we reduce or even keep it at a plateau of C&D waste production? So again, just to contextualize where I'm coming from, we've seen over the last 18 months, 24 months, a lot of really good guidance coming out about planning authorities, from planning authorities, especially London, and also very good guidance on for clients, and just general good guidance around circular economy more generally and holistically, which is beginning to inform the supply chain in Ireland. Over the last 12 months in Ireland, we've sort of built on that, and we've released a number of things, such as you can see there, a series of checklists or beginner fact sheets that we developed in conjunction with Southern Waste Region in Ireland, which are just introductions for the different stakeholders. And there's also been a series of webinars which have commenced in the last couple of months, which are focusing on the circular economy. And these are all being supported by various policy documents in the work of the Irish Green Building Council, which means that it now is becoming to the forefront of the thinking in the construction sector. And David Cheshire, as you're probably all familiar with it, has a nice graphic outlining the different principles moving from different layers of decision making, which is what I sort of want to talk to you about today, and also incorporating different design principles and the hierarchy of retention, refurbishment, and reuse, and designing out waste, and designing for adaptability, and so on. So really good principles from a design and a planning point of view. So when we look at the planning and we extract guidance out of the planning, more generally, they're looking at, designing out waste, maintaining value and utility, and the conservation of resources, as you all well know. And that's repeated, I suppose, in client guidance with an expanded focus, obviously, on the operation of an asset and maybe the deconstruction of an asset in the longer term. Excuse me. But what I wanted to talk to you about today is, consider this, though, from an SME context, and more particularly an SME main contractor context. And there's a whole range of challenges there. One challenge is the interpretation of what the circular economy actually is. So SME contractors on site understand waste because they can see it, and they don't necessarily understand what the circular economy means. So that's an issue. The traditional competitive bid process, which is very fragmented, is a challenge. The very short timelines between tender award and commencement on site. The high importance of cost, which is all persuasive at times, and the lack of planning, client and design sustainability requirements for projects of this scale, and if they are included, they mostly focus on low energy design. However, there are some opportunities that present themselves when you dig into the business model of an SME. One of those is the tendering and procurement strategy of their own supply chain, because it tends to be quite repetitive, and it's dealing with micro SMEs, of 5 to 10 people or less, and also what they can do from an on-site management point of view. So the question, I suppose, is what role can an SME contractor play in a circular built environment? And so how we approach this on a current project is to build on previous work. So in previous work, we focused on benchmarking and improving resource efficiency best practice on small and large scale projects using a simple methodology that you can see on the screen, which looked at observation followed by low cost quick win recommendations and implementation and tracking to develop key performance indicators. And so this worked really well, and we developed a series of case studies, one with a large scale contractor, BAM, and one with a small scale contractor, Kerry Building Contractors. And we also developed a series of fact sheets, and these were disseminated and shared across industry to demonstrate that resource efficiency can be achieved without having a high input cost. So what we decided, or what we discovered from that, was to continue this work with the SME partner, Kerry Building Contractors, to look how they can transition from resource efficiency good practice to more circular practice. And we found that the main driver has been the development of a resource management plan for each project, irrespective of whether it was asked for or not by the planning authorities, client or design team, as this provides a structured approach to engaging with the supply chain in the pre-construction planning and construction phases. And so what we've seen is, some good practice following this intervention, which includes source segregation on site, the employment of take-back schemes with suppliers, direct reuse of offcuts on site, also proper material storage. But some challenges were also identified in relation to non-returnable packaging, for example, cement bags, poor material storage on site, and indirect waste that doesn't actually end up in the skip, which you can see down there in the bottom right corner, but occurs all over the site. So we decided to expand the role of the resource management plans by requiring the supply chain, so these micro SMEs, to complete their own resource management plan checklist to demonstrate a willingness to comply with the project targets. And so as you can see in one of the case study projects, we had a mixed result from subcontractors, but a very positive result from suppliers. But in general, both stakeholder groups agreed to optimize orders, minimize packaging where possible, participate in take-back schemes, comply with site rules in relation to segregation and materials management. So we're currently analysing this case study data to determine the impact of this in comparison with similar projects which had no resource management plan supply chain requirement whatsoever. So although in general this has demonstrated a gradual willingness to engage in more resource efficient and circular practice on site, it is in effect a reactive process. And so what we want to do is to go back to what I mentioned in the beginning, is the whole understanding of circularity, and to frame that in an easy to understand way. So what we decided was to reconceptualize the idea of waste, because waste is what contractors understand, and to look at it as a resource and a language that site personnel will easily understand. So we return to the main driver, which is cost, and more specifically, the true cost of waste. And so in the graphic there, you see a selection of skips from one of the case study sites, and we've identified the costs in green and the costs in red. So the costs in red are the costs that they would appear under monthly waste reports, but the costs in green are maybe costs that they haven't included. And so we went a little bit further then, as we started breaking down the skip size by looking at the original purchase costs of materials that are now wasted in skips, to hopefully begin to stimulate a more preventative and circular mindset. And this is informing training interventions, education interventions that we're using on sites, so site posters, toolbox talks, and so on. So for a long time, main contractors, especially SME contractors, has thought of recycling as best practice. And so we're now looking to move the sector away from this towards more preventative approaches, where designing at waste and reuse are the default approaches. This will obviously require earlier interventions from the planning authority, client and design team. So it's a sort of a retrospective analysis, as we're looking from the site and working backwards in this case. And so what we've done is we've updated our case study methodology to identify opportunities where we can embed circular economy principles at an earlier stage and track the impact at each stage. And we're working with a number of clients at the moment doing just this, working from pre-demolition audits, pre-refurbishment surveys, and working our way through the design elements, the procurement elements, and so on. Finally, I just want to share some good news in relation to how this ongoing research is informing curriculum and program development in GMIT. We received funding in September 2020 from the Irish government to the tune of over €7 million to establish a digital academy for a sustainable built environment with our partners listed here. And one of the main outputs will be the development of an MSc in circular economy leadership for a sustainable built environment, which is currently under development. And we use a reciprocal learning framework, which you'll see on your right there, which basically combines industry best practice, applied research, collaborating with industry to inform our curriculum development. So we see research-informed and evidence-based curriculum development as key to everything we do. That's my presentation. If you have any queries after the event, please do not hesitate to contact me at this email address, and hopefully I'll be able to answer any questions that you may have. Thanks very much.
Thank you, Mark. It was very interesting to see the progress in Ireland on this topic. I'm asking now again, Paula.
If you hear me now, otherwise we.
Much better, much better.
Yeah, because I changed. I have a Mac, and sometimes they don't correspond with the Chrome.
Exactly, that's what some people already suggested. Very good. So, Paula, then I propose that you share your screen. Yeah.
Yeah, you see it now?
Yeah. Yeah, we can see it. Please make sure you use the presentation mode.
I think I do that, but I'm not sure if you see
yeah,
that.
this is perfect.
Okay.
Go ahead,
So,
Paula. Collaborative
yeah.
approaches.
Yeah, thank you. So I'm going to shortly present collaborative project, the project where we collaborate between countries and between academy and industry in the search of more circular kitchens as one important component of buildings, which is often replaced prematurely. And we are in this project not only researching circular solutions, but also producing circular solutions. So it's a 4-year project. In the Netherlands, we have partners at TU Delft, Professor Vincent Groos, and the Swedish team is led by Professor Ulrike Rahe. And we have 2 teams, and both teams work with the national context. So the Dutch work with the Dutch situation and the Swedish with Swedish partners and the Swedish situation. And the ambition is, or the goal is, to reach market-ready circular products in both countries, which will be different projects. In this paper, I will give some critical perspectives on the ongoing project, its approach, and its outcome. The project is financed through the Climate Kick and also by industry partners in each country. So background and motivation. Swedish Insights studies on home renovation was a study I made some years ago where we could identify that most of the climate impact material flows from internal occupant-driven renovations came from changes in kitchens, as you can see in the picture I attached. Most of it is related to kitchen appliances, but also for as much as 14% were related to kitchen furniture replacement. The Dutch situation had, the Dutch team had already proof of principle for plug-and-play kitchen furniture, which could be designed as a circular solution. So together we applied for this research funding and got the money. And the ambition for us is to increase the longevity of kitchen and improve the flexibility of the kitchen, which allows for changes over time, which we know will happen. So the Swedish Kick project, as I said, we are an academic partner. Together in the team, we also have a kitchen producer, a national kitchen producer, a housing developer, one of the larger housing developers in the country, producing mainly occupant-owned apartments. We also have an international appliance producer in the team. In Sweden, we have the possibility of testing new solutions in purpose-built facility, a living lab, which we have on the campus of our university, which is also a partner in this project. I'm going through the different parts of the project, the different approaches that we have done. We have worked a lot with the collaborations and co-design processes within the national team with our partners, and in international collaboration with the Dutch partners, the Dutch industry partners, and the academic partners. In Sweden, we have also worked with insight studies of end users, supply chain studies to understand the current business models. We also work with spatial studies relating not the kitchen only to the furniture, but how the furniture interact with the rest of the home and the apartment. We have also done some market studies, and we have worked with prototyping. I will go more into detail to these different parts here. So first, we have done user insight studies, working with diaries, focus group, deep interviews, home visits. We have also done workshops in our living lab and cooking events. And we also used students, we have introduced user insight studies in student assignments among architect students. The ambition of these user insight studies has been to understand current use and changes of a kitchen, but as well as future needs of new kitchens as one part of input for the new kitchen we're developing. Supply chain and a market study. We have had the intention of understanding current and possible future business models. understand the influence of the physical infrastructure, which is already in place, how that can be used or have to change in order to produce more circular products. Also the influence of the value appreciation in different parts of the value chain. We have also identified gaps in the value chain, for example, a lack of the end user perspective. And we made this questionnaire, a market study, where we actually have almost 1,700 respondents in 9 countries. Spatial aspect of circularity is something that has not been studied that much. It has been part of some research which I've done before, and we have had one of our doctoral students in this project, which have worked with relating spatial characters to produce more circular kitchens. So she has studied contemporary apartment layouts and kitchens, identified kitchen topology, size and layout, and relation to other rooms, and assessed the potential for adaptability as one important part of circularity. Design for circularity, we have had another doctoral student working with co-creation, understand how this can work and produce support for that. For example, he has produced something called Cards for Circularity, which is a kind of a tool to enhance collaborative processes for a new design. And these have been tested both on professional actors and design and architect students. Prototyping and testing. We did a first prototype, which was actually more of a state-of-the-art of the kitchen today, on movable parts, so that we could try out different layouts and setups. And we had different cooking events and workshop with actors, architects, designers, professional chefs, to see how which kitchen they preferred, and testing it live. We also had some student assignment in the kitchen. And then in later part of the project, we have made a new prototype based on our research and experiences and involving external designers. And we also made extensive material research for the new prototype. Where we are now is that we are planning to test this new prototype in 3 kitchens during this year, and then larger tests in homes in the coming years. So some reflections of the process. This has been a quite large project. We have been able to, in Sweden, employ 3 doctoral students, which have different expertise and have different directions, different focus areas, which has been a way to gather and be able to carry out all this different research work. We have parallel teams in the 2 countries, which have been very fruitful for exchange, not only research and knowledge. In Sweden, we had more focused on the user aspects, supply chain, while in the Netherlands had more focus on LCA and the business models. We have also been able to inspire and motivate our industry actors through these collaborative workshops and meetings. There's been a good crossover between academy and industry. The open process we have had also led to some spin-offs. I already mentioned the Cards for Circularity, but we also have another idea of a product service system. These are both unexpected and valuable additions to the project. There is at the moment a large interest among clients in the Netherlands. They are installing kitchens this year, and we are also preparing for installing kitchens, these prototype during the year. Some challenges, especially in Sweden, the kitchen producer have been hesitant to change. It will change for more circular solutions, different kinds of materials. It will be necessary for them to change the machine park, and it's quite expensive. They also have a current successful business models, have been a bit reluctant to change that. And now during COVID, conditions have changed even further. There is also a conflict between practical advancements and project leading and academic requirements. Of course, sometimes funders and the industry doesn't really understand how research work and the conditions through which we have to let the PhD students work. They also take a lot of courses, for example. And due to COVID, we also had a severe cut in funding during the last year, which we struggled with. But we are now working with new applications for a KIC 2.0, as we say. This will be to practically test our prototype 2 and commercialize it with the help of clients. So that was my presentation. Thank you for your patience, and
thank you, Paula. Perfectly in time, so that's great, and nice to hear about this. I think we are all curious how you will continue. And we all use the kitchen every day, so I think everybody can imagine what this is about. Thanks a lot. Questions? People are really chatting a lot, so don't hesitate to use the chat for any questions. We still have one presentation to go, and that's from Lisa van Gulck. We are going back to circular assessment again, and her presentation is about facade systems. So Lisa, I hear you. Can you also share your screen?
I will share my screen. Normally it should be okay now.
Yeah.
Okay. So hi, I'm Lisa van Gulck. I'm a PhD student at Ghent University, the research group Building Physics. And I will talk a little bit more about a circularity assessment method for facade systems that was developed during one of the research projects. So a lot of authorities have identified the circular building strategy as a very important strategy to reduce the environmental impact of the building sector. And this recognized urgency to move towards a circular economy is very positive. But as was already said during one of the first keynote lectures, we don't actually have an exact definition for what the circular economy is. A study by Kircher showed that there are over 114 definitions of the circular economy. And this broad scope makes it very hard to define what a circular product is and which aspects we need to focus on. So when we translate this to the building sector, this results in the question, what criteria must a building meet in order to be considered a circular building? Different methods to measure the performance of a building on circularity do exist, and these are what we call circularity assessment methods. They score different building solutions on circular parameters. Then the Eureka project, or effectively upscaling the renovation of envelopes with a circular approach, is a 2-year research project funded by the Flemish government under the Circular Flanders initiative. The goal of the project is to develop a circular facade system that is scalable and allows existing high-rise buildings to be renovated quickly and in a circular manner. The different facade systems that are thought out during this research, they should be compared in an objective way on their different aspects, but most importantly on their circularity, because one system may use materials with a low environmental impact, but that are connected irreversibly, while other system may use materials with a higher impact, but they are connected reversibly, so they can be reused. To make this objective comparison, a circularity assessment method will be used. Partners in this project are the building consultancy agency Bureau Bouwtechniek, a contractor Van Rooij, and aluminium constructor De Witte. So different circularity assessment methods already exist. But when analyzing these, none seemed completely appropriate to evaluate the facade systems of the Eureka project. Existing assessment methods often evaluate circularity on building level, while for the facade systems, we want an evaluation on element level. Existing methods often require a lot of detailed information, such as the geographical origin of materials, and they also ask for project-specific information, such as the use of BIM models or material passports. While we want to use this method for early-stage decisions, and when nothing else than the construction method and general material choices for the facade system have been made. So, based on the analysis of existing methods, a new circularity assessment method is developed that allows to evaluate circularity on element level during an early design stage. The new method consists of 6 different parameters. The first one is recycling, which takes into account the recycled content and the recycling potential of the materials. The environmental cost relates to the environmental impact of the materials. The expected service life relates to the circular principles that we want durable materials with a long lifespan, and that the construction should be layered according to lifespan. The fourth parameter, component dependency, relates to the dependency of components within one layer. Can we adjust one component without altering the other ones? And then the fifth parameter, layer dependency, is about dependency between layers. The last parameter, flexibility for reuse, is how, to which extent are the materials, can they be adapted for reuse on a different building? So for the parameter environmental cost, the score is defined for the whole system at once. All material layers and connectors are included. But for the other parameters, first the score is given per material layer, and subsequently these scores are added to get a total parameter score. In general, for the new method, the rule is the higher the score, the less circular a solution. To comply with the circular principles, independent layers, and reversible connections, building solutions often require an additional material layer. And this is illustrated when we compare an ATIC system with a ventilated facade system. An ATIC system is actually a relatively simple facade system. You have your bearing structure, the insulation, and then a plaster layer that is connected to the insulation. Very simple, but it does not comply with either of the circular principles. Then the ventilated facade has an additional wood supporting structure that disconnects the insulation with the facade cladding. And therefore, it does comply with both circular principles, but it does have an additional material layer that needs to be taken into account when giving a score on the parameters. And therefore, a distinction is made between parameters which focus on the material aspect, such as recycling, expected service life, and flexibility for reuse, and parameters that focus on the layering aspect, component dependency and layer dependency. For parameters with the focus on the material aspect, the total parameter score is obtained by weighing the score of the material layer with the relative contribution of that material layer to the environmental cost. We want materials with a high environmental impact to have a high recycling potential, a long service life, and that they can be reused. So it's logical that they have a higher contribution to the total score. For the parameters which focus on the layer aspect, the scores of the material layers are just added to one parameter score without weighing. So now that we know what the parameters are and how the scoring is done, the assessment method can be applied to ATICs and the ventilated facade. For each material, for each system, the different material layers are displayed and their contribution to the environmental cost. Per parameter, a total score is given. And then there's also an average score, which takes into account the average of the systems. Then for each parameter, a relative score is defined, is the score of that parameter compared to the average. Because by using a relative score, all the parameters are set into the same unit, and we can add them all up to a single score. So the assessment method, it does not set benchmarks, but it does allow to compare the systems and choose the most interesting one. You can see the individual scores per parameter, and you can have a single score. And the single score is obviously the most easy to base your decisions on because there's only one aspect you need to take into account, but it can be argued that, that some information is then pushed to the background and that actually representing the score per parameter is better, such as is done with the radar chart. It also gives you the opportunity to optimize the system without worsening the score on the other parameters, but it does make decision-making less straightforward. So the developed method allows us to measure circularity on element level with only a limited amount of information necessary and without the need to have a specific project in mind. And this allows us to make decisions in an early stage. This method will then be used to compare the circularity of the systems thought out in the Eureka project in an objective way. The method was now thought out for a facade, but it can also be used for other building elements, and it was also applied to renovation scenarios, But in hindsight, the parameters are independent from a renovation or a new build scenario, so it can also be used for new build. For other projects, other parameters can also be added to the method if they seem relevant. Thank you for your attention, and if there were any questions, I will be happy to answer them.
Thank you, Lisa, and at least you get a good comments in the chat, so well done.
Thank you.
So we still have 15 minutes for a Q&A. And I'm very happy that you all have started the Q&A in your in the chat box. So I'm wondering where to start. But maybe we can have a reflection on the various assessment methods. I heard about a material circularity indicator in presentations. The second presentation, the assessment of Lisa, and the last presentation. And maybe first question for Paula. Did you also use this type of assessment methods to assess the circularity of the kitchen? It was one of the questions also in the chat.
Yeah, they did in the Netherlands, but actually in Sweden we have not come that far at the moment. We don't have that kind of competence in the group, but we have relied a lot on material assessments done by the Dutch team.
Okay, thank you. And maybe a similar question to Michiel. In the project on concrete recycling, you assessed the energy efficiency and the CO2, which are obvious, of course. Was there any circularity assessment in the sense of a material circularity index or other type of circularity assessment?
No, we started this line in the project 3 years ago, and it was actually still before the MCI and BCI real big movement. So we didn't include it yet, although now we are working on it with some of our students to look at BCI indicators of these elements. So it's a very relevant point we still have to pick up.
Okay, thank you. And then where the Superlocal project did a lot on also the technical aspects of the material. There were also some questions about did it fulfill new requirements, which you already answered, Michiel. Thank you for that. Then a question to Lee. You have in your material circularity approach, you do have something on degradation of material. Did you specify it, like which would be very relevant for the concrete in Michiel's project, or is it just a generic deterioration factor? You have to unmute yourself, Lee.
Yeah, thank you for reminding me. So currently my master's following with the MCI's focus on the product level. So focus on the components. So I also use the facade, the building facades as my focus to validate the model. While because the facade is built in a totally new lightweight materials, no include the concrete. So I'm not that sure if these methods can be also used for the concrete one.
Okay, it would be an interesting discussion if.
Well, I think it is, and actually, it's a very important point that we should be working on if we want to really accelerate the implementation of the possible reuse of materials. We have to come to a value creation system in which the end-of-life value is elaborated on. So, for instance, in a linear way of thinking, you build a house. So we build houses with social housing associations, and after 50 years, these houses are have no value anymore. So for them, they can destroy it, demolish it, and start building something new. But to make something circular, we need to invest more at the front. and then we have to have some kind of residual value at the end. Actually,
This is also what I'm thought before. So that is also the reason why I build the independence indicators named residue value, because I think quite important that you can evaluate the residue performance after end of life. So that can encourage the users to reuse or recycle once again.
Yeah.
Great, nice interactions between the different research areas. A question for Mark on the Irish project. There were many questions about the SMEs and if they were interested in it, and being aware of the
I bounced some of the responses there back in the chat. Generally, if you walk into a construction SME contractor and you ask them or tell them about circular economy, they don't really have any idea what you're talking about, because one of the questions was related to BIM. The challenge we have in Ireland is for projects of a certain scale, say €5 million and less, a lot of times they're not being asked by clients to be a BIM project or to have a certain amount of sustainability criteria related to them. So the smaller scale projects are being missed out on the large exemplar €200 million project. You'll see a lot of sustainability requirements. You'll see BIM being developed and so on, and you can look at the synergies between the two. But the challenge at the moment, and what we've focused on over the last 18 months, is starting to work with some public sector clients, so government clients, and getting them to look at their responsibility from a planning authority point of view, but also a client point of view, that they would sort of make these requirements sort of mandatory in their procurement and tendering, and the supply chain then would follow. But we sort of want to map the impact of asking these questions into tangible, outputs on cost and so on, and the level of circularity and so on. Otherwise, it'll be very difficult to diffuse it back in to the SME sector. Generally, if they're not being asked for it, they won't do it, because time and cost is such an issue with them. But saying that, the participants we had on the projects were very open to it. In fact, they approached us in a number of instances and said they would like to look at this. And that's sort of how the collaboration began. So it's a mixture, it's there's no one set.
Yeah, I understand. And would any regulatory measures help, like increasing the rates for landfill, for example? So increasing costs for landfill, or maybe a mandatory pre-demolition audit?
Yeah, so we have been increasing our landfill fees for a number of years, and some of our landfills actually do not accept construction demolition waste. But then construction demolition waste is one of the highest waste that has illegal dumping. So you're in a sort of catch-22 situation there. So that's exactly what we're looking at. For the last 12 months, I've been working with RPS on the development of the new C&D waste guidelines for the construction sector. And in those set of guidelines, which should be due out in the next couple of months, we've recommended, so we can't make it mandatory, but we've recommended that all planning authorities have a planning condition to prepare a waste and resource management plan as part of planning. So if the local authorities, and we're working with some of the local authorities at the moment, if they implemented that, it would change the whole dynamic, because it's embedded, it's mandatory, it's regulatory, and so on.
Yeah. Great, and the super local example, and here already shows that it can be very beneficial to cooperate with the local authorities in such situations. Great. I was wondering, Lisa. We heard Paula talking about a collaborative approach and also new insights like products as a service. Did you also include such product as a service concepts in in your assessment method?
It's not part of the assessment method, but it is part of the broader research project, that it is researched how the facade panels can be used as service, product as a service, that buildings actually lease them for a certain period and then they can be reused on another building again, and the owner always stays the producer of the panels. But it is not in the assessment method.
Okay. And Paula, then, you were talking about lack of end-user perspectives in one of your slides. I was wondering, what is the lack of perspective, and would such a product as a service concept help to provide a perspective for end users? Because you can just give it back.
Yeah, that is something which we would like to develop further, that you can change, because I mean, nowadays, at least maybe not always, but often you throw out the whole kitchen. Well, the idea of this circular is that you could change parts which are more often damaged and more often changed. For example, in Sweden, we have very strict regulation on how a kitchen should be delivered, and it doesn't always correspond to what people want. So there might be one part of the kitchen which will always be there due of regulation, but it will be changed later. So the idea is that you could easily identify what part you would like to change, and that you could change that part. And the idea is to get some circular business model around this this exchange of parts. But then there was another question you had. No, yeah, how to get the user perspective in. Of course, if it is possible to track this. This was one of our starting points when we started. We wanted to track if the, the businesses, they know what things, the services they sell after sales services, but they don't really know what happened with the kitchen over time. But with some digital imprint, with the digital follow-up of these, they could also get more information on what happened with their kitchen, the lifetime of the products, etc., with some kind of a digital system adapted to it. So I think that would be most smart, because going out and doing questionnaires, I know this is very interesting, but it's not really cost efficient, of course. Yep. But at all, we should know more about, as architects and developers, we should know more about how people live in their apartments, and also understand changes of cultural and changes of lifestyle, and what kind of homes and kitchens we need to provide in the future. Yeah, so maybe both digital and some qualitative studies.
Okay, thank you. And thinking of product as a service is often seen as a solution for circular to obtain circular products. But sometimes you hear a manufacturer can take back something, but they still don't recycle it. So now a question for Mark: if you manage to give back material, to identify materials, separate it on site, and send it back to a manufacturer, how is it assured that the materials are recycled?
Yeah, so from a main contractor point of view, you're not sure, because they once the material leaves the site, whether it be waste in a skip or the materials in the take-back scheme, the contractor's responsibility sort of ends. So one of the things we're looking at is trying to track where do the materials end up, and we have a repack initiative here, which is the recycling of things like cardboard and plastics and paper and that sort of stuff. So we can say that if it was packaging, that is going into a recycling loop, and we track it to the waste recycling facility. But then where it goes from the waste recycling facility onward is interesting, because in Ireland we have a real limitation around markets. So a lot of materials that are being recycled in your household recycling are actually ending up being pelletized and shipped abroad for energy recovery and incineration. And I think in the UK, Dispatches did a program on this a couple of weeks ago. The BBC did a program on this. And of course, it's not something that wants shared widely with the general public, because then you'll have the impact of people not bothering recycling their materials, because they'll ask themselves the question. But the limitation around the whole market for secondary products be they downcycled or upcycled products, is a real issue in Ireland, just by the nature of our size and so on. But there are a number of initiatives, especially around social enterprises, that are looking at this issue, but it hasn't been fully addressed yet.
Great, thank you. So I see that there's a lot of interest in all the research. You are very well chatting around. That's great to see. We are coming to the end of the session. I could have asked many more questions to all of you, but just is there someone who wants to ask a last question, which is very urgent? No, otherwise
maybe just one question, which is also posted in the chat. The proceedings. Do you know anything about the proceedings?
I don't know anything about. I received the proceedings as a chair, so I thought you would have them too. So I really do hope, and otherwise ask the organization again. I guess that
Yes.
we will all receive them. The papers are in there. Otherwise, you have the names of our speakers. You will definitely find them or somewhere in the conference program, or otherwise via the usual social media channels, whatever. We are coming to the end of the session. I want to thank all the speakers for their very interesting contributions, and all the participants for their very active participation and questions. I hope to see you all. I'm going to throw you out of this session, and you are going back to the lobby, and we are going to stop the recording now.